So it is integer type question, either numerical type. Are you getting?
Newton दिखाते हैं the height of sir 5 meters. Am I audible, sir?
Are you getting the answer?
Sir, I'm getting, sir.
You are not audible. Speak louder.
Sir, I'm getting, sir. Hello, sir.
So tell me the answer. Voice is very low.
Sir, now I'm audible, sir.
Hmm.
5 meters, sir.
Yeah, that is correct. Okay. So let's go to the next, and now we will try some JE question. So this is an old IT JE question. Try this one. IT JE 2010 paper one question. Question is visible, no?
Yes, sir. Question is visible, sir. No issues.
Okay.
Sir, fourth option is what?
I will show you fourth option.
Yes, sir. Now it's showing. Sir.
This is fourth option, right?
Yes, sir. The first option is correct, sir. Total moment of system is 3 kg per meter. Sir.
You are saying first option.
Yes, sir.
Okay. Yes, first option is correct. One more option is correct. Check it.
Sir, can you show third and fourth option, sir?
Sorry.
Sir, can you show third and fourth options?
Hmm. So you can find velocity of center of mass,
Yes,
and then you can find the
sir.
kinetic energy.
Then option C also correct, sir.
Hmm.
Candidate is 0.7.
Yes. So these two are the only correct options of this question.
Yes, sir.
A and C. Okay.
A and C. Yes.
Yes, A and C. Others are wrong. Okay. So let's go to the next question asked in JEE Advanced. Try this one. Question is visible?
Yes, sir. Question is visible, sir.
Okay. One minute. These are all the options. This is the question.
Yes, sir. I'm sorry.
Yes, you can ask a doubt.
So calculating side first of all.
Okay.
So 500 meter per second. Sir, am I audible, sir? Sir, 500 per second. Meter per second.
Hmm.
Sir, 500 meter per second.
500.
Meter per
500
second.
meters per second. Okay. 1 minute. Let me check. Five hundred meters per second. You are getting. One minute. Yes, that is correct answer. 500 meters per second is the correct answer. So last option, fourth option is correct.
Yes, sir.
Okay, good. So you saw that in all the question, conservation of momentum is coming.
Moment. Yes, sir.
I'm giving you one more question. So now you can try this question. JEE Advanced 2013 paper 1. Is it visible?
Yes, sir. It is visible, sir.
Okay. Try this one. So this is saying completely inelastic. This question involves completely inelastic collision. This one, perfectly inelastic collision. So it is a type of collision in which there is maximum loss of kinetic energy and the relative velocity of separation after the collision becomes zero. Because relative velocity of separation becomes zero, so coefficient of restitution becomes zero. But momentum remains conserved. So coefficient of restitution is zero. Maximum loss of kinetic energy takes place, and relative velocity of separation along the common normal becomes zero. That's why coefficient of restitution becomes zero. So now, based on this, you try this question. You can ask your doubt also.
I will try, sir.
Yes, are you getting? You have any doubt?
So 1 minute, so I'm getting, sir.
Okay.
Sir, pi by 4, sir. Hello, sir. So the angle is pi by 4, sir. Sir, pi by 4, sir.
Yes, tell me. Are you getting?
Yes, I'm getting, sir. Pi by 4,
Pi by 4 you are getting, okay?
45 degree.
Okay, 1 minute. Let me check. Yes, correct. Correct answer is option 1, 45 degree. So this is the correct answer. So all these were JEE advanced questions. Now you just keep solving, complete SCV from this chapter. Are you getting? There is, I think, a separate chapter on this momentum and in SCV. So
Sir, it is. I will do all the questions, sir.
yeah, so do all the questions from that chapter. You'll gain confidence. Now here in such type of collision, perfectly elastic, always there will be loss of kinetic energy. So then they will ask you in some question, find the loss of kinetic energy. Loss of kinetic energy will be simply initial minus final kinetic energy.
We can do.
Maximum loss of kinetic energy takes place in a perfectly inelastic collision. Yes, tell me.
So either we can do final minus initial or initial minus both are.
Final minus initial will come negative, and negative simply means loss. Okay. So suppose you are doing final minus initial, it is coming minus 25 joule. But they are asking you how much is loss. So loss is not minus 25. Loss is 25, right?
Yes. But sign indicates the loss in energy.
Yeah. So if there are two options, minus 25 and 25, and you will tick minus 25, it will be wrong,
Oh,
right?
yes. Yes, sir.
That's why initial minus final will give you loss. Okay. Now,
But either we do final minus initial, we get loss, but we
yeah,
should control the magnitude
yes.
most.
Yeah. So just
That
you have
negative
to understand that
indicates.
negative is giving me loss. Yes.
Yes, sir. Okay, sir.
Or they can ask you what is the gain in kinetic energy, and then you can tick minus 25. Are you getting?
Yes, sir.
So it depends on the language. Now head on and oblique collision. So then again now the collision can be different, it can be classified in two different ways. First is head on collision, second is inelastic collision. So let's try to understand what is the line head on collision. Head on collision, so this is a type of collision in which the particles move along the line joining the center before the collision and also after the collision. So for example, you can see that this is one particle, this is another particle, and this is the line joining the center of both the particle. If their initial and final velocities initial also, final also. All the velocity are along this line, then it is per head-on collision. So initial velocity, final velocity, all are along this line. We will call it as head-on collision. Sorry, head-on collision. Okay.
So we can take that line. Uh, so means every question is head-on question we can say. So because for every two bodies colliding, we can draw a line connecting them. Also.
Yeah, but it their initial velocity may not be along the line. For example, this is the case that suppose this is the first particle, this is the second particle. First particle is moving in this direction, second particle is moving in this direction, and they collide at some point here. Are you getting?
Yes, sir.
And now you can see that their initial velocity and final velocity are not along this line joining. Are you getting?
Yes, sir.
This is oblique collision. So in which initial velocity you can see is not along this line and final will also be not along this line. So this is oblique. So you understood what is in. So you can also call head-on as 1D collision and the oblique collision as 2D collision, because in head-on particles are moving on a single line. That line you can choose your x-axis. Now in case of head-on collision, the question is very simple because it is 1D. So you have to only there is one component of the momentum. But when it becomes oblique, then two components of collision will come. Because you can now break it into two components. For example, you can see like this situation that there was a particle kept on x-axis. Another particle is coming, traveling on x-axis. It strikes and then the particle goes in any direction. You know? So here you can see that finally it is moving along this axis, moving along this axis. Now its momentum is in this direction, which can have two component, one component x component and y component. So in such situation, you can break it into components and then you can apply the conservation of momentum separately along x-axis and separately along y-axis.
So means we are considering the line joining the two bodies as a reference line or x-axis. We can consider and solve it. In that way also we can solve it.
Yes, you can take that. You will
And
do
that
few
will
questions, then you will understand. Yes. Yeah, tell me.
make somewhat easier than considering x and
That you can take. Means which line you are saying you will take?
means the line joining the two bodies. Sir. You can see.
Yes.
So that is called impact line. We can see.
Yeah. So that is also called as a line of impact. Yes. Now you can try this question. Try this question. Here you have to understand that the whole diagram is in horizontal plane. Rod is not vertical. Rod is kept on the floor, horizontal. It is lying on the floor. This is also on the floor, moving. Are you getting any idea?
I'm trying, sir. Respond.
Okay. This is JEE advanced question. Fine.
Hello, sir. Hello, sir. Hello, sir. Am I audible, sir? Sir, hello. Am I audible, sir? Hello, sir. Sir, hello, sir. Hello, sir. Hello, sir. Sir, hello, sir. Hello, sir. Hello, sir. Hello, sir.
Tell me, Prabhakar, got the answer?
Yes, sir. I got, sir. 1/4.
1/4. So
Yes, sir.
what you did, what you applied here?
Sir, first of all, hello, sir.
Huh. Yes.
Sir, sir, we have considered before collision the velocity of particle is V1. Velocity of rod is 0, sir.
Yes.
After collision, equal that velocity of particle comes to experience velocity of particle 0 and rod is V1. We can apply
Uh,
conservation of momentum and angular momentum and linear momentum and each.
okay. And then you applied conservation of angular momentum. Why you applied conservation of angular momentum?
Sir, what, sir?
Why you applied conservation of angular momentum? Is it applicable conservation of angular momentum here?
Yes,
How
sir.
can you see?
About the
Yeah.
center of mass of the rod, it's approvable now, sir.
Yes. So above the COM it is
Applicable.
applicable. Correct. That is, so you are getting 1 by 3.
On the four, sir.
Answer given is 1 by 3. So,
1 minute.
okay, you made a mistake here. What mistake you made is that you have not considered the angular, means rotational kinetic energy of this. After collision, it will have this velocity as well as this velocity also, right?
Yes, sir. Yes, sir. I forgot.
You have
Due
only
to
considered
rotation.
half mv square, not considered half I omega square. That is your mistake. So it will have velocity v. If you do that, then you will get. You can see this solution. This is the solution, you can see. Conservation of angular momentum and initial kinetic equal to final kinetic.
Yes.
Okay. Are you getting? Now you can try this question. Look at this question. This is again JEE advanced question. Try this one. This is the complete question. Are you there?
Hello, sir. Yes, sir. You.
Are you trying this question?
Yes, sir.
Okay. You have any doubt, you can ask. Are you getting it? So I think this question is not much related to.
It is a friction and that's a rotation motion.
Yeah, so this is related to friction and rotation only. Okay, if you want, we can go to another. So we were simply, so we completed actually most of the concepts, and only after doing questions you will get. There are some more concepts are there. For example, if suppose this is one sphere and this is the line passing through the center of that sphere, and here one another particle is there. It's like this, and it is approaching like this horizontal. When this particle will reach here, when this will reach here, but it has to be little lower, I think, so that it hits the so like this, and then it will hit here, strike here. Okay. It will strike here, let's say, and it is spherical, so situation will be somewhat like this, say, let's say, and then this will be the center of first, and here is the center of the second, and center of the second, and this line if you join is the line of impact. Now let's take it like this, that this one is going and striking here, let's say. Going and striking here. That's coming. Now after hitting, it will exert force in the direction of the common along the line of impact. So it will experience a force in this direction, and this will experience a force in this direction, Newton's third law. Because of that, its velocity direction will change. Initially it was going in this direction, after that it will start going in some other direction like this. And the direction of first, because this one was at rest, so it will start moving along the line of impact because it experienced force along that direction. Let's say after collision its velocity becomes v1 and its velocity, let's say, becomes v2. And then here you can say that, let's say this angle is alpha and this angle will be, let's say, theta. And here this particle has mass m and this particle has mass capital. This is the same particle of mass small m. Okay, so here what you will do, and suppose that the coefficient of restitution is also given for this collision, that E is 0. Let's say 0.6. So now you have to understand that in this type of collision, oblique collision, the coefficient of restitution formula you will apply along the line of contact. So coefficient of formula simply says that the relative velocity of separation after the collision by relative velocity of approach before the collision. But here you have to, in case of oblique collision, you have to take relative velocity of separation after the collision along the line of impact. Means you have to take its component along the line of impact. So along the line of impact, if you take the component, then the component will be, one is v1 and plus another is v2 cos theta, right? See, they are going in opposite direction. And divided by relative velocity of approach along the line of impact. Let's say initial velocity is u, then it will be u cos alpha. U cos alpha. So this is one equation that you will get from the coefficient of restitution formula. This is equation number 1. Then what you will do? After that, now you can apply conservation of linear momentum. Conservation of linear momentum is conserved in any direction for the whole system, I am saying. So for the whole system, you can conserve momentum in any direction. Also, you have to understand that for individual particle, also momentum will be conserved along the common tangent. So this is the common tangent, which is perpendicular to the line of impact. Now this is line of impact, so I am writing here LOI, line of impact. This line is the line of impact. And this line is common tangent. Are you there?
Sir, I'm there, sir. Hello, sir.
This line is common tangent. Along the common tangent also, initial momentum of individual body, not system, will be conserved. Why? Because if you see this body is experiencing force along line of impact during collision. but then no force along the common tangent. Because the force is along line of impact, so that force has no component along common tangent. So linear momentum of this particle individually is also conserved along the common tangent. So now I can write its conservation of momentum of only this particle along the common tangent. So what is its initial momentum along the common tangent? That is mu sine alpha. So I can write that, okay, mu sine alpha is its initial momentum. And what is the final, its momentum after the collision along the line of impact? That is mv2 sine theta. Angles are different. So I got this equation for the second. This particle momentum is already conserved along common tangent because its momentum along the common tangent before collision was 0, and after collision is also 0 because it is going along line of impact. Are you getting?
Yes, sir, I'm getting, sir.
Yes. Now you can write, so you have I think this equation, that equation, and you can conserve the whole system momentum also, and that will be conserved in any direction, along line of impact, along common tangent, along any direction, whatever direction you choose wisely. So that also you can write. Solving all those equations, you will get the answer. Are you getting? So this is the concept here in this type of question. You can write the conservation of momentum of the whole system along the line of impact. You will get one more equation. So like this, you can apply these concepts here and solve. So now just keep doing questions from the collision, from your material, from SCV. And I think in the next class we will do, in 1 hour, I will discuss few questions and we'll complete it. Now nothing is left, right? Now we can start electrostatics.
So I will discover him, then I will say, sir.
Okay. Okay. So just go through it, and then after that, yeah, you tell me, and then we will start the combined class. Also inform Himanish.
Yes, sir. I will.
Yeah, we'll start the combined class. We'll continue. So you keep solving questions, come with your doubts.
Yes, sir.
Okay. Keep solving SCV. Try to complete SCV as fast as you can so that some time is left and then we can go for Eurodo.
Yes, sir. I will solve. I will complete SCV by over 4
Yeah.
hours.
Okay, then we'll continue tomorrow, I think.
Yes, sir. Thank you.
Okay, all the best. Bye.